Alright, now this next part, which is the last video I'm going to make for this unit now, going back to when I did an erase, there is another thing that you're going to have to do in this unit, which is a big part of this unit, and that is doing story problems that have to do with maximums, minimums, and being able to find like the maximum volume of something. I just feel like that's kind of review, and I don't need to explicitly do that in a video, and if someone requests that, I will. But as right now, I think that you just use your prior knowledge, and you can do it. There'll be problems. If you ask, I have tons of those practice problems I can explain, but where you have to find like what the maximum volume of something would be. But it all relates back to basically the last two units, this unit and the unit before, mixed into one to do that, and I think you guys can do it. So the last thing we're going to talk about is slope fields. Slope fields are basically having to do with these concepts of differential equations, which I told you before is a different name for derivatives. It kind of is, and there's a whole unit later this year on differential equations where you guys are going to have tons and tons of fun with that and logistics. But I'm not going to get into that right now of explaining what exactly these things mean. I'm just going to go ahead and tell you how to do them for as much as you need to know how to do this unit. This is what a slope field looks like. A slope field, as you can see right here, there's tons of little tick marks that I've drawn in, and what a slope field is it's basically what the slope is at certain points. Now, why would you want to know that? And the slope, by the way, is let me say this again. You're going to be given a derivative. So for this first example, I'm going to do dy dx. Yeah, dy dx equals 2y. Maybe you're a little confused why there's a y there, and that goes into the differential unit, which we'll be doing a lot later. But just let's look at this and say 2y. I am going to show you how you can kind of get a sketch, I would say, of what the antiderivative of this, or if this is the derivative, the thing you took the derivative of, is going to look like. Just a little kind of guess. And the next unit is called Antiderivatives and Integrals, where we're actually going to find out how to do that. But for right now, you just need to know how to kind of approximate it. And the way that we do this in slope fields is we basically plot points, but we're plotting the slope at certain points. Why? Because this is a slope line. This is telling you the slope of the line. So if you draw all the slopes out, then you might be able to draw what the original graph looks like. Now, disclaimer, you don't know how high or low it is, because as I've explained, I think 3 times so far in this unit's videos, if something is f of x equals x plus 5, once you take the derivative of this 5 is going to go away. So this could be 6 for all we know. If we just know that f prime of x equals 1, then we know, going back and doing reverse power rule, which we'll do so much in the next unit, but we know there must be an x here. But there can really be any constant after that, and for that reason, we don't know how high or low this line is going to be unless you're given more information. But using slope fields, we can get approximations. So a lot of times in these problems, they'll give you a point that exists on this line, and then you can kind of do an approximation with that. So all I'm going to do for this one is I'm going to draw an xy grid, and let's do back 2 and forward 2. But how do we do this? Well, we're going to make a little chart where we're going to put y on one side of the chart, and we're going to put the dy dx, similar to before when we would put x here, but there's no x in here, so putting x's in here is not going to help us. We're going to have to put y's in. So, because this graph right here goes from y equals -2 to y equals 2, let's just do -2, -1, 0, 1, 2. Now, because there's no x in this, it's going to be the same along the x-axis, aka the slope's going to be the same along the entire thing, because the x doesn't make a difference, because there's no x in here. So, whatever you get for this value, that's going to be the slope at each of these points for the entire horizontal line unto infinity. So y, -2, well, -2 times 2 so it'll be -4. -1 times 2 is -2, 0 is 0, 1 is 2, and this is 4. So then what we're going to do is we're going to go ahead and plot some slopes. Now, a lot of times you're going to want to be very, very, very careful, exact when you're doing it, I guess I should say. So, for all the times that y is -2, you're going to make the slope -4. It's going to be something like that. For all the times y is -1, it's going to be -2. This is a very big sketch because I don't have like a what's it called, a straight edge to help me. Here it's going to be 0, then here it's going to be 2, and here's going to be 4. And so now the problem says that there's a point that exists at 0, 1. So we would put this here, and we would kind of just go along with the slopes that we have, and you'd see that the line's going to look something like that. And that's how you can kind of go backwards. Now, there's going to be slope fields where they're going to have x's and y's, and to do that, you're just going to have to take a coordinate by coordinate. You don't get to take a shortcut where, oh, if you plug in -2 for y, it's going to be the same for all of the points that have y of 2. If there's a question, I'm not going to do a whole question like, or a whole situation like this, but if there's one that says, oh, if it's y over x, well, we're going to have to, if we're doing it on a 2 by 2, you're going to literally have to do it for every single point. -2, -2, -2, or -1, -2, 0, -2, 2, -1, 2, 0, 2, and so on and so forth for all 25 points that are on here. Although you'll probably be able to find patterns, and it probably won't take you as long. You don't have to show the work on your sheet a lot of times, though. You can just do it in your head. So that's a slope field, and that's basically the transition to our next unit, which is antiderivatives and integrals.